Hello my friends and welcome back to KrossUSA channel. Today we're diving deep into the fascinating world of wood workshops, from the pristine forests of Russia to the rolling hills of Alabama, and finally to the scenic landscapes of Switzerland. So grab your favorite coffee and let's get started. We're taking you on an incredible journey from the pristine forests of Russia's Kirov region to the cutting-edge facilities of Holzhaus, where traditional craftsmanship meets modern engineering. If you've ever wondered how those beautiful, eco-friendly timber homes come to life, you're in for a treat. We're starting our adventure in the dense forests of Dorovskoy district, where Holzhaus begins their sustainable timber journey. These aren't just any forests. We're talking about carefully managed woodland where every tree is selected with precision. The company uses advanced GPS mapping systems and drone technology to identify mature trees that are ready for harvest, while ensuring younger trees remain untouched for future generations. NNTHE harvesting process begins with skilled foresters using Ponce harvesters. These Finnish-made machines are absolute marvels of engineering. Watch as the operator maneuvers this 20-ton beast through the forest with surprising grace. The harvester's computer-controlled head can fell a tree, strip its branches, and cut it to predetermined lengths in less than 2 minutes. The precision is remarkable. Each cut is calculated to maximize yield while minimizing waste. Now here's where it gets really interesting, folks. Once the trees are processed into logs, Holzhaus employs a sophisticated logistics system that would make Amazon jealous. Ponce forwarders, these are essentially 8-wheeled forest tractors, carefully collect the logs using hydraulic cranes. The operator's skill is crucial here. They're not just loading logs, they're organizing them by species and quality grade right there in the forest. NNTHE transportation phase showcases some serious heavy machinery. We're talking about Volvo FH16 logging trucks capable of hauling up to 60 tons of timber. These aren't your average big rigs. They're equipped with specialized logging trailers featuring hydraulic loading arms and sophisticated load securing systems. The drivers navigate winding forest roads with loads that tower 12 feet high, requiring exceptional skill and experience. What's particularly impressive is Holzhaus's real-time tracking system. Every truck is equipped with GPS monitoring, allowing the mill to know exactly when timber will arrive and plan production accordingly. This isn't just efficiency, it's environmental responsibility, minimizing fuel consumption and reducing the carbon footprint of their operations. As our timber convoy arrives at the Holzhaus facility, prepare to witness industrial choreography at its finest. The logs are first weighed on massive truck scales. We're talking about scales that can handle 80-ton loads with accuracy to the nearest kilogram. This data feeds directly into their production planning software. NNTHE unloading process utilizes overhead gantry cranes with 40-ton lifting capacity. Watch the precision as operators use radio controls to position logs exactly where they need to be. The logs are sorted into different yards based on species, primarily Siberian pine and spruce, and quality grades. This isn't random stacking, it's strategic inventory management that ensures optimal drying and processing schedules. Here's where modern technology really shines. Each log receives a barcode tag containing information about its origin, species, moisture content, and intended use. Holzhaus uses CT scanning technology, yes, like medical CT scans, to analyze the internal structure of premium logs, identifying knots, grain patterns, and optimal cutting strategies before a single saw blade touches the wood. Now we're getting to the heart of the operation. The sawmill itself. Holzhaus operates a state-of-the-art bandsaw line manufactured by Söderholm Ericsson from Sweden. This isn't your grandfather's sawmill. This is precision manufacturing at 21st century standards. NNTHE primary breakdown begins with a twin-band head rig that can process logs up to 24 inches in diameter. The saw blades, razor-sharp bands of Swedish steel, move at speeds of over 100 feet per second, cutting through Siberian pine like butter. Computer optimization software calculates the most efficient cutting pattern for each log in real time, maximizing yield and minimizing waste. What follows is a symphony of automation. Edgers trim boards to precise widths, trim saws cut exact lengths, and grading scanners analyze each board for strength characteristics. The lumber moves through this process on a network of conveyor systems and transfer chains with minimal human handling. Quality control operators monitor every step, but the heavy lifting is done by machines that never tire and rarely make mistakes. NNTHE dimensional accuracy achieved here is impressive. We're talking about tolerances measured in millimeters. This precision is crucial for glulam production, where boards must fit together perfectly to create strong, reliable structural elements. Here's where things get really exciting: the transformation of ordinary lumber into engineered glue-laminated timber. This process represents the perfect marriage of traditional woodworking knowledge and modern materials. Science in first, the lumber enters massive kiln drying chambers. Think of them as giant ovens for wood. These kilns, manufactured by Valutech from Sweden, can hold up to 200 cubic meters of lumber and use sophisticated moisture and temperature controls to dry wood to exactly 12% moisture content. This process takes 3 to 5 days and is crucial for glulam quality. Too wet and the glue won't bond properly. Too dry and the wood becomes brittle. NNTHE gluing process is where precision becomes paramount. Boards are fed through finger jointing machines that create interlocking joints stronger than the wood itself. Henkel's structural adhesives, specifically formulated for load-bearing applications, are applied with robotic precision. The application rate is controlled to the gram, ensuring consistent bond quality. Now watch as the boards are assembled into massive laminated beams up to 40 feet long and 3 feet wide. Hydraulic presses applying up to 500 tons of pressure compress the assembly while the adhesive cures. Temperature is carefully controlled during this process. Too hot and the glue sets too quickly. Too cool, and it won't cure properly. NNTHE final phase showcases Holzhaus's commitment to both quality and environmental stewardship. Every glulam beam undergoes rigorous testing using ultrasonic equipment that can detect internal flaws without damaging the product. Stress grading machines apply controlled loads to verify structural integrity. NNBUT. Here's what sets Holzhaus apart. Their environmental innovation is remarkable. Wood waste from the process doesn't go to landfills. It feeds biomass boilers that provide heat for the kilns and factory heating. Sawdust is compressed into pellets for renewable energy. Even the bark stripped from logs becomes landscaping mulch sold to local gardens. NNTHE finished glulam beams are destined for eco-friendly homes that can be assembled in weeks rather than months. These aren't just houses. They're carbon-sequestering structures that lock away atmospheric CO2 for decades. When you see the finished product, those beautiful exposed beam ceilings in modern timber homes, you're looking at the culmination of this entire sustainable process. And we wrap up our visit to Holzhaus. It's clear that this represents the future of timber construction: high-tech, sustainable, and incredibly efficient. Next, we're heading across the ocean to see how American companies are revolutionizing hardwood processing. Welcome to Alabama, folks, where Maplesville Tie and Timber Company has been perfecting the art of hardwood processing for over 3 decades. And we're in the heart of Alabama's mixed hardwood forests, where oak, hickory, and maple trees have been growing for 60 to 80 years, reaching their prime for harvest. Unlike the coniferous forests we saw in Russia, hardwood harvesting requires different expertise and equipment. These trees are denser, more valuable, and require careful selection to maintain forest health. And Maplesville uses Tiger Cat feller bunchers, purpose-built American machines designed specifically for hardwood operations. These 35-ton beasts are equipped with cutting heads that can handle oak trees up to 30 inches in diameter. The key difference here is selectivity. While softwood operations often clear-cut designated areas, hardwood harvesting is more like surgical extraction, removing only mature trees while preserving the forest ecosystem. NNTHE collection and transportation of hardwood presents unique challenges that showcase American ingenuity. Tiger Cat skidders, these are tracked vehicles with winches, extract felled trees from locations where wheeled equipment can't operate. The terrain in Alabama's forests includes steep slopes and creek bottoms that would stop conventional logging equipment. At the landing areas, you'll see some impressive American iron, Peterbilt and Kenworth logging trucks, equipped with specialized hardwood trailers. These aren't the long log trailers we saw in Russia. Hardwood operations typically use shorter, heavier loads due to the density of the timber. A load of green oak can weigh 50% more than a comparable load of pine. What's fascinating about Maplesville's operation is their species segregation system. Hardwood buyers are incredibly specific about species, grade, and intended use. Oak destined for railroad ties must meet different specifications than oak intended for furniture production. The company uses color-coded marking systems to ensure logs are routed to appropriate processing streams. Now here's where Maplesville really shows their expertise: manufacturing railroad cross ties that will support America's freight rail network. This is precision manufacturing, where safety and durability are literally matters of national infrastructure. NNTHE primary breakdown utilizes a massive Wood-Mizer circular sawmill. This is American engineering at its finest. The head rig can handle logs up to 36 inches in diameter, slicing through dense hardwood with carbide-tipped blades that cost $500 each, but can process hundreds of logs before replacement. And railroad ties aren't just cut lumber. They're engineered products that must meet strict American Railway Engineering Association specifications. Each tie must be exactly 8.5 feet long, 9 inches wide, and 7 inches thick, with tolerances measured in fractions of inches. Automated measuring systems verify dimensions continuously, rejecting any ties that don't meet specifications. NNTHE tie production line is a marvel of American industrial efficiency. Gang ripsaws cut multiple ties simultaneously from large cants, while automated handling systems move the heavy timbers without human lifting. A single production line can output over 400 railroad ties per hour when running at full capacity. NNTHE final phase of Maplesville's operation demonstrates why American railroad ties are exported worldwide. The pressure treatment process is fascinating. Ties are loaded into massive cylindrical pressure vessels called retorts, where they're subjected to preservative chemicals under 150 psi of pressure. This isn't just dipping wood in chemicals. This is materials science. The pressure forces preservatives deep into the wood fiber, protecting against insects, fungi, and rot for decades. The process takes 8 to 12 hours per batch, with computer controls monitoring pressure, temperature, and chemical concentration throughout. And quality control at Maplesville goes beyond specifications. It's about pride in American craftsmanship. Every tie receives visual inspection, and random samples undergo laboratory testing for preservative retention and penetration. Rejected ties are reprocessed or diverted to lower-grade applications. Nothing goes to waste. NNTHE finished ties are impressive. Each one will support trains weighing hundreds of tons for 20 to 30 years in service. When you see a freight train rolling across America, you're looking at the culmination of this entire hardwood processing system. The ties beneath those rails represent generations of American forest management and manufacturing expertise. In an A's, we leave Maplesville. It's clear that American hardwood operations combine respect for natural resources with uncompromising quality standards. Now let's cross the Atlantic to see how Swiss precision applies to timber processing. Welcome to the breathtaking landscape of Entlebuch, Switzerland, where the Schmid sawmill represents 5 generations of Swiss precision in timber processing. If you think Swiss watchmaking requires precision, wait until you see how they approach forestry and lumber production. We're in the heart of the Swiss Alps, where spruce and fir trees grow slowly in harsh mountain conditions, creating some of the world's highest quality timber. These aren't plantation forests. We're talking about natural woodland that's been sustainably managed for over 200 years. The elevation here means trees grow slowly, developing tight growth rings that produce incredibly strong, stable lumber. NNTHE harvesting operation showcases Swiss ingenuity adapted to mountain terrain. Lieber cable yarders, these are specialized Swiss machines, can extract timber from slopes too steep for conventional equipment. Picture cables stretching across mountain valleys, with logs flying through the air like wooden zip lines. The precision required to operate in this terrain is extraordinary. One mistake could send thousands of pounds of timber tumbling down a mountainside. NNTHE Schmid mill itself is a testament to Swiss engineering philosophy. Everything has a purpose, and everything is optimized for maximum efficiency. The mill utilizes a combination of Austrian and Swiss machinery, including Wintersteiger bandsaw technology that represents the pinnacle of European sawmill engineering. And what sets Schmid apart is their approach to log optimization. Using 3D laser scanning technology, every log is digitally mapped before sawing begins. Advanced software calculates cutting patterns that maximize value yield. Not just volume, but actual market value based on current lumber prices and customer demands. This isn't just cutting wood. This is precision manufacturing applied to a natural resource. NNTHE sawing process demonstrates Swiss attention to detail. Bandsaw blades are maintained to tolerances measured in thousands of inches. Blade tension, tracking, and sharpening are monitored continuously by computer systems. The result is lumber with surface quality so smooth it often requires no further planing for high-end applications. And here's where Schmid really shows their Swiss DNA, the value-added processing that transforms commodity lumber into premium products. Their planing mill produces tongue-and-groove flooring, wall paneling, and structural timbers finished to furniture quality standards. NNTHE moisture content control is remarkable. Kilns equipped with both traditional heating and innovative dehumidification technology can achieve moisture targets within 0.5% accuracy. This precision is crucial for high-end applications where dimensional stability is paramount. In Schmid's finishing department showcases traditional craftsmanship enhanced by modern technology. CNC machining centers can produce complex timber joints with tolerances measured in hundreds of millimeters. Yet hand-finishing skills passed down through generations ensure that each piece meets the aesthetic standards expected of Swiss craftsmanship. Perhaps most impressively, Schmid operates as a carbon-negative facility. Their biomass energy system not only powers the entire mill operation but also heats 200 homes in the local village. Wood waste becomes renewable energy, bark becomes garden mulch, and even sawdust finds use in particle board production. NNTHE finished products from Schmid represent the perfect integration of natural resources, traditional knowledge, and modern technology. Whether it's structural timber for luxury chalets or precision-milled flooring for high-end construction, every piece carries the guarantee of Swiss quality. As we conclude our global journey from Russian forests to American hardwood operations to Swiss alpine precision, one thing becomes clear. The timber industry represents humanity at its best, respecting natural resources while applying knowledge, skill, and innovation to create products that enhance our lives and built environment. Next time you walk through a beautiful timber, until next time, keep exploring, keep learning, and keep appreciating the amazing world of craftsmanship around us.